All right, good morning, everyone. Today we've got a little bit more methods, and then we're going to jump into arrays. When it comes to the last little piece of methods, it really sort of utilizes sort of all of the sort of method ideas with return values and different numbers of parameters and all that sort of normal stuff that we talked about. It's just something to do with the naming. So that's the sort of method overloading part, and then we'll jump into arrays after that and sort of start talking about them anyway. We'll probably finish with them on Tuesday. So to begin with, if you ever see this sort of terminology, this sort of overloading terminology, and most of the time it doesn't matter what language it is, it usually means that you're sort of doing something with whatever the object is, so methods in this case. You're doing something where you're sort of using that object, that thing, to do more than one type of operation. So method-wise, we can use the same method name to do different things under certain conditions. So that idea is method overloading. In some languages, there's like operator overloading as well. So you can change how the plus sign works, for instance, or how the equals sign works, for instance, in some languages. Java typically doesn't allow that sort of thing, but for methods, it does. This is most useful when you have multiple methods that are going to serve a similar purpose, but maybe one of those methods, say, takes integers and the other one takes doubles. You could make two different methods with two different names. That's perfectly fine. That's something that folks do all the time. But method overloading actually allows you to use the same name for two different methods, two or more different methods, provided that you follow a few rules. So the rules, they're relatively simple, but they are very strict. If the number of parameters in the method are different, then you can do it. If the types of the parameters are different, then you can do it. It's allowed. So something has to be different in the parameter list, either the number or the types. Changing just the parameter names doesn't mean anything in terms of these method overloading rules, and changing the return type doesn't matter either. So I want to give you an example of this, sort of a concrete example to start with. We're not going to specifically code this one up, but I want you to look at the two methods that are here. So here we've got inside a main, we call this method called max twice. So the name is the same for both calls. It's max. But the first call to max only takes two arguments. The second call takes three. So even though it's the same name, we can send in different numbers of arguments. Why? Because we have two separate methods with the same name. This is overloading. So the method max has been overloaded. One of them only takes two doubles, and the other one takes three doubles. That satisfies our requirement. We need a different number of parameters, which is what this case is, or different types of the parameters. If one of these took ints and the other one took doubles, that would satisfy the requirement as well. Both of these return double as a return type. Just changing this, just changing that return type is not good enough. So it's got to be something in the parameter list here that's different. So the number or the types of parameters. The benefit of this is that you don't have to remember that you have two separate functions, that you have a max for two values and a max for three values. You don't have to remember that when you're using your code. You just use max and you put in two values and it works. You use max, you put in three values, it also works. That's the idea of overloading. You're essentially giving this method more capabilities, more things that it can do in terms of its input and potentially its output. The specifics of exactly how this is working, it's not super important because the main thing here is that we're calling max twice with different numbers of parameters. If you want to take a closer look at how we're getting the max of 2 numbers and the max of 3 numbers, you can certainly do that. That's the basics of overloading. So it's not too complicated, but you do have to follow the rules on it. I do have another example. This one is the different types example. So we have doCalc. We're calling it with an int. Remember, if I put a number straight up like this counts as an int. Here I'm running doCalc now with a double. If I put a 0.0 or something like that, something with a fraction, just a straight up number as a fraction, it will count as a double. So the first doCalc runs this one. This one takes an int and it returns an int. The second doCalc is running the second one here. Takes a double, returns a double. So 2 essentially different functions, they just have the same name. So you can do different things with them. You can send in ints and doubles. Now, depending on sort of which one of these you had, if you only had one version of this, both of these situations may work where you just put in a number 42 and 42.0. So it depends on exactly how you code it up. But in this specific case, if we find a doCalc that takes an int, that's the one we use. If we find a doCalc that takes a double, that's the one that the code is going to use. So Java is smart enough to look for the correct version of the method that you're trying to use. And of course, we catch that return value in the appropriate type as well. So these have different return types, but again, that's not the only thing that can be different. Something has to be different inside of the parameter list. So the int and the double here, the types have to be different, or the number of parameters like we saw in the previous example. But of course, we do have to catch the correct value in here. So we need to, for the first doCalc, we catch it as an int. For the second doCalc, we catch it as a double. So I got a couple pop-ups that sort of show up in there. Okay, so there are a few gotchas here. Again, this isn't that complicated. So, but there are a few gotchas here. So the method that is actually used, it's found by an exact match. At least that's the first thing that Java tries to find. So it tries to match the number of arguments and their exact type. So like I said, if it's an int, Java tries to find the int version of that method. It will search for something that's close if it can't find the exact match. So that's something that we sort of get more into in like CS2 class as to sort of why it does these certain things. But essentially, it tries to find the exact match first. If not, then it will try to use something else if it can. Again, you can't overload a method when it's only the return type that is different. It has to be something in the parameter list, so the types or the number. And then, like I said, the exact match first. Otherwise, the automatic conversions take place. So you can go from an int to a double, right? A 42 is just 42.0 as a double. So it tries to find the exact match, but it'll try to sort of search for something else if it can't find the exact match, something that works if it can't find the exact match. So potentially that could sort of trip you up if you're like, why is it using this particular function when I have another one that is maybe closer or maybe you think is closer? Java is determining stuff underneath the hood without any of your input at all. Most of the time, at least for this class, you're not going to have to worry about if you do some overloading, you're probably not going to have to worry about exact match versus almost exact match for finding the correct method to run. Java should be able to figure that out for anything that we write here. But as we get into sort of the higher up classes, there might be some issues that you end up running across. So I'm going to show you how I sort of go about coding up one of these overloads. So we're going to write 2 methods, both named area. One of them is going to compute the area of a circle. So the nice thing about that is we only need one argument. The only thing that the area of a circle depends on is its radius, or its diameter, whichever one you would want to use. The second version of area is going to compute the area of a rectangle. So we've got two parameters that we need to worry about there, the length and the width. And then we'll write a quick main to test them both out. And I actually don't think I have Eclipse open yet, so let me do that. So this is going to satisfy the requirement that the number of parameters are different. Our first version of area will have one parameter. Our second version of area will have two. I'm going to allow doubles for all of these, so we can type in sort of whatever number we want. That means that when we get the area back, we need to have them both return a double, so that we can actually print it out properly and then have the correct value for the double. All right, so move that back over. Okay. All right, so we have main, but let's write the methods first. So remember, when we go in and write our own methods, we're going to say public static. That's going to be the stuff that we write for now. We're going to put that basically all the time. And I talked about area. What do we need to return? Well, if we send in a double, something with a fraction, we're going to get something with a fraction back out. So I'm going to make sure we return a double. So it's going to be something with a fraction. I'm going to call it area. And I need one parameter for the circle version, two parameters for the rectangle version. So let's do the circle version first. So I'm going to say double radius. So that's my parameter. And here I can say this is the circle version. All right, so now we just need to compute the area of a circle based on its radius. So I'm going to say return. You could put an extra variable in here, compute the area based on save it into a variable and then return that variable. I'm just going to use the return sort of right away and put a math equation right after the return. If you want to access pi, you can literally type in 3.1415927 or 265, however many decimals after pi you remember, or you can use math.pi if you haven't used that before. So this is pi, that is a double, so it shows you actually what the value is here. And then I'll say times radius. So pi r squared, that's our area of our circle. So it's going to run that calculation and then return that as a double back to main, or wherever we call it from. So that's my first version of this method. So that sort of goes back to our lecture sort of last time, talking more about methods. Like, all right, we've got one parameter, one return type. We make sure to return the value using that return type, using the radius that gets sent in. So now we're going to write the other one. We're going to write the rectangle version. So I'm going to start with public static. We're still going to return a double. We're going to allow the user to type in doubles. So if we type in something with a fraction, we should get back something with a fraction. We'll say area, and then this time we're going to have two parameters, double length and double width. Remember, these are the inputs to the method. So if I want to compute the area of a rectangle, I need to have the length and the width. I'm going to do the same thing I did with the circle version. I'm going to return the calculation. So I'm going to say length times width. So whatever this calculation ends up being, whatever number I end up getting out of this, that's what gets returned back to whoever called the method, which will be main in our case. If you wanted to do this with an extra variable, so if you wanted to create another variable, we could. I could say double area or double, I don't know, rect area or something like this, something to represent the variable. And I could say length times width. And then here I would return the rect area. So if you want to use an extra variable as part of this, that's perfectly fine. It's not going to really be any different than just having the calculation be returned. But if it makes more sense to do something like this, then that is what I recommend doing until you get sort of more familiar with using methods and returning values and things like that. So we can create a variable in our method, have it be the result of the calculation, and then return that variable. So you can do the same thing for the circle version as well. So now up here, we could say something like, so in main, I could say double, and let's say this is the C area. I'll use a lowercase here. So this will be the circle area. So if I just put in, if I do a call to area and I say 5.2 like this will use this version. Because I put in one double, it is going to use this one. That will give me the circle area. And then, of course, I could print that out. So I can say area of circle and put in, I don't know, 0.3f or something. A new line, and then put in C area. And then I could do the same thing again for the R area. So this time I'm computing the area of a rectangle. I call the same method again, but this time I might put in, say, 2.5 and 3.7. So that's calling area, but this time it is this method. Because I have two doubles, it's now going to run that particular version. And it's going to give me back a double. So again, I'm catching the result that comes back into our area in this case. And then I'm just going to copy this line. And this will be the area of my rectangle. So if I run, we get the area of the circle and the area of the rectangle. So it did, in fact, run those separate functions. So that's the idea of overloading. This is not something that you have to use. You don't have to use overloading. You pretty much don't have to use it ever if you don't want to. A perfectly reasonable way to change this to not use overloading is to say, let's see.
Just out of curiosity, why did that work when you have two different variables for rectangle area?
Yep. So for here, this is the version. So Java. So I guess this is sort of the easiest way to say it is that behind the scenes, when you run your program, Java sees that there's the function call. So it sees that, hey, we're calling a method. It's called area. Where does that exist in this code? Where should I go to run this? So it's going to look at the parameter list first. It's going to say, okay, there are two parameters. They are both doubles. So does there exist a function called area that takes two doubles? So in this particular case, yes. So this will choose, Java behind the scenes will choose this one to run because it has an exact match. It sees two doubles for the parameters, use that one. Whereas for the circle one, it sees one parameter here. And so it looks for an area method that only has one parameter. And so then it will automatically choose, I need to run that one. I need to run this first one.
Okay,
so
thank you. I understand.
Yep. So it's looking specifically at that parameter list. It is a lot of behind the scenes stuff, and a lot of programming languages do this sort of thing. In CS2, we actually learn a little bit about that process, what exactly is happening behind the scenes to make these decisions. But for now, know that it's looking at the parameter list and it's trying to find that exact match so that it knows which one it needs to run. Now, again, you don't necessarily have to do this. I could do something like area C, area R, and then I could just call the appropriate one, and everything here would work exactly the same way. So if I have this saved, there. So in this case, they're two separate methods. There would never be any confusion. There's only one method named area C, only one method named area R, and those are the ones that get run. So you never have to do overloading. But it can be useful because then you don't have to remember, get rid of the area R and area C. For something like specifically like max that I showed as one of those examples in an earlier slide, you don't have to remember what the name of the specific function is. If you have a function that computes the area, all you have to remember is if I put in one value, it's going to be a circle. If I have to put in two values, it's going to be a rectangle. That's what it's going to give me. Or for max, if I put in two values, I get the max of those two values. If I say max and I put in three values, I get the max of those three values. So you don't have to remember that there's two different versions of max when you're sort of writing the rest of your code. So overloading can be convenient. I think that's probably one of the most important things here. It is more of a convenience than a requirement. Let me show you one more example here. So let me get rid of everything here in main. I'll show you one more example. I think it is on the slides here. So the sort of solution to this is here. Here I did rectangle first and then circle next, but whatever. The sort of next sort of example exercise thing is write three methods, name, display, result, that prints a single value to the screen. So they're just going to print one thing, but one prints an int, one prints a double, one prints a string. So this one could particularly actually be useful for stuff in sort of your homework or personal projects or whatever, because it gives you one method, at least one method name, that can sort of look like it does multiple things. So as an example, as this sort of work this one out, let's write those three different methods. They're going to look almost identical. So we need public static first. These don't return anything. Their whole purpose is to just print something out. So if all they're doing is printing, they don't need to return, so that's going to be void. If nothing gets returned from these, you can just put void, and then you're good. And I'm going to call this, instead of typing out the display result, I'm just going to say disp result. And this one, let's say this one takes an int. So it takes an int. I'm going to call this int value. And we're just going to print out the value. So I'm going to do a printf. I'm going to print out %d value. So that's it. That's all this one does. And I can literally just copy and paste this, the whole function. And let's say this is the one that's supposed to do a double. So how do I print a double? I use a %f. Okay, easy enough. And let's say this next one, so I'm overloading these because I'm changing the type. The number isn't different, so I still only take one value, but now the type is different. So let's say this one is a string. For strings, you do %s. So the only difference between each one of these methods is the type that I take in and that little conversion character, a %d, a %f, a %s. But now in main, all I have to do to print different things out is just do my disp result. And I can send in a number. And I can call the same function again. And I can send in a string, like a %n for a new line. And I can do the same thing again. And I can send in, let's say, 5.6. So when I run, I guess I'm using a printf. Yeah, so this is printing it literally as a string. So I'd probably want to, let's do something like this. I may need to use a different conversion character or something for if I wanted to put a new line in. So here is what we get. We get the 5 printed. We get the n printed. We get 5.6. I could send in something like a space here, for instance. So I get 5, 5.6. The point here is if you just look at main, if we forget about all the functions that we just wrote that do these sort of different things, what it looks like from the perspective of main is that this function can do multiple things. Because it looks like the same function because of the overloading, but it looks like it can do multiple different types of things. It can handle different types of input. And that's because we wrote the functions that handle it and tell it sort of that it needs to do something different. Printing an int is very different than printing a double. It's different than printing a string. But it looks like the function can handle any of it because of the overloading that we did. So this is probably, compared to the previous little exercise that I coded up, this is probably a more useful one. Because if you want to print out ints and doubles and just use one function call to do it, then you can overload and you got your function call done. So that's the idea of overloading. That's what's happening here when you overload. And again, it's more of a convenience, but it can be quite useful. So I have a sort of a similar one here like this. All right, so the take-home points of this sort of overloading thing is that multiple methods can have the same name. That's the point. That's method overloading. But they have to have a different parameter list. So if you overload a method, it needs to either have a different number of parameters or the parameters must have different types. Changing just their names does not matter, and changing the return type does not matter either. Most commonly, this is actually used when doing similar calculations with different types of arguments. So that's sort of the most common way that you'll see it. You'll see it specifically in this class. If you programmed before and you've used sort of other APIs, as an example, I'm teaching a game dev class at the moment. Oftentimes, when it comes to using a particular library, there are many different types of overloads. So overloading is used extensively in libraries. So you can do one function call, but send in potentially 5, 6, 7 different types of actual types or numbers of arguments. And so that's something that for the library you would have to learn, but you can do it for yourself. So you can sort of create your own sort of versions of this overloading stuff. So that's the method overloading thing. Again, it's not too complicated. Mostly for convenience, just remember methods can have the same name, but the parameter list has to be different in some way. That's sort of the overall take home. So before we switch over to arrays, does anyone have any questions? Okay, so arrays are probably the simplest sort of data structure that you're going to learn about in CS1 and probably CS2 as well until you get to the data structures class if you're a CS major. It's really just a list of variables of the same type that are usually related in some way. So let's say, for example, I need to keep track of 1,000 items. This could be anything. This could be 1,000 names. 1,000 student names in a particular major or something, right? It could be anything. So 1,000 items in some way. In principle, I could use 1,000 variables. So if I needed to keep track of 1,000 doubles, I could create literally 1,000 doubles. I could have double num1, num2, num3, num4, num5. I could keep track of all those. That's a lot of typing. Typically, more typing when you're programming means more chance for errors. This could work for sort of whatever you're trying to work on, but a better way to do this, a better way to store these potentially thousands of items, is to use an array. It's a much more compact way to do it, and it's pretty much ubiquitous everywhere. Every language has some concept of a collection of similar items, a collection of similar items with, say, the same type, for instance. So in Java, an array is actually an object. So it's actually kind of like scanner. Or you can think of it maybe kind of like a string, a collection of things. A string is sort of closer to an array because a string is really a collection of characters. But there is some different syntax to it. There's a couple of special symbols that denote an array. Those are the square brackets. So we've seen parentheses. We've seen the curly brackets. Now we have the square brackets. So they do mean something specific. So if you see square brackets, typically that's going to represent some kind of an array. So rather than create 1,000 doubles like I showed in the previous slide, or at least I showed a couple of them, the idea is to create space, or to create those 1,000 doubles in one line. So we have the type, the name, and the initialization. It's exactly the same as creating any other variable. I create a variable if I want to say double num equals 10, it's the same style. Except now the type now has these brackets. The name follows all the same rules as the names we've talked about before. And the initialization is slightly different as well. We have some brackets, we have this new keyword, so it's kind of closer to a scanner in terms of initialization, but we use these brackets and we have the type here again. So we have the type there. So let's dig into this line a little bit more. So we start with the variable type. Whatever we want these variables to be. In this case, I want to create a double array. So if you want to create an array, the sort of language you should use, if you were to sort of say this line out loud, I would say double array. Cost is a new double array with 1,000 elements. That's how I would sort of say out loud what this line is actually doing. So you always start with the type you want, followed by brackets. And the brackets don't have anything in them. That's just denoting this is an array. So this is a double array. You do the normal thing for name, all the same naming conventions. You can't use special characters. All that normal naming convention stuff. The next thing after your equals then for your initialization is the new keyword. New does some specific things that we'll sort of get to in the future. But for now, just think of it as creating a new array. You're saying there's this double array called cost, and we need to create a new array. We put the type again. So these types, they must match. So these two types, they have to be exactly the same. Then you put the brackets again, but this time we put the number in it. And that's the size of the array. So right here is the size. So in this case, it's going to be 1,000 doubles. So cost is a double array that contains 1,000 doubles. That is a way to look at this line as well. So that's your basic, so if you want to create an array of some specific type with a certain number of elements, this is the way to do it. That number in the brackets, that 1,000, that's the maximum number of elements that array can hold. So I can't put more than 1,000 doubles into this array. It's not possible. What it's doing behind the scenes is it's actually creating memory in your RAM. So it's creating space in your RAM, I should say. So your actual RAM chip in your computer, your desktop or your laptop, whatever you're using, it's going to create space for 8,000 doubles. Remember how big a double is in terms of size. We talked about it in week 2 or whatever. A double is 8 bytes. So this is creating, when I do this new double, when I do this piece of the initialization, this is setting aside in your memory, so in your RAM on your computer, it's setting aside 8,000 bytes. 1,000 doubles, 8 bytes each. So in your RAM, you're using 8 kilobytes to store cost. So if you made this number bigger, say you wanted 1 billion doubles, not just 1,000, 1 billion doubles. That's 8 gigabytes of doubles. That'll probably get pretty close to filling up your RAM. If you've got 16 gigs, you can hold a lot more. But this is where some of that sort of memory stuff comes in. It's very easy to use up a lot of memory on your system if you're not careful about the size of your arrays and is sort of cognizant of the amount of memory you actually have. Now, on our computers, for the homeworks, for the labs, you're not going to have to worry about creating gigantic arrays that fill up your memory. But in the future, if you're doing stuff, say, with our hardware stuff, so you may have heard like Arduino and stuff like that, you may only have a couple of kilobytes of memory on the piece of hardware. In that case, even 1,000 doubles might fill the memory on some device you might be using. So if you do end up doing stuff with like Internet of Things, embedded sort of AI type stuff in the future, which we have classes where you can do that sort of stuff, memory is at a premium there. So even now, as you're sort of learning programming, learning Java, sort of learning how to deal with some of these concepts, it is sort of worth thinking about that this isn't just some sort of magical thing that happens that, oh, now I have 1,000 doubles I can use. It is using physical memory in your computer. All right, so you can sort of think of an array as actually declaring the same number of individual variables. So this line, and let's think about what this line is doing, int array called counts is equal to a new integer array of size 8. So it's 8 integers called counts. It's kind of like doing this. I create a counts 0, 1, 2, 3, 4, 5, 6, 7. That's 8 total integers, counts 0 through 7. It's kind of like doing that. Not exactly. There are sort of reasons, there are very good reasons why doing this sort of bottom way is not going to be nearly as useful as doing it in this top way, and also sort of performance-wise as well. But we don't really have to worry about that too much. So it's kind of like doing this. But in your code, you could probably take 8 values like this, and you would sort of know what to do with them. You could say like counts 3 equals 5, and counts 7 equals 10. It's sort of easy to deal with individual variables, at least right now, if you've never seen arrays before. So how do we deal with these variables? I have 8 values, but I only have one name. The name is counts, but I do have 8 ints in there. So to access the array elements, to access the individual ints inside of that array that I created, we use the index. This is a slightly different usage than the usage of brackets that we just saw. So it does use brackets, it's just in a different context, and this can be slightly confusing. So as an example of this, let's say I create an integer array called values, and it contains 15 integers. So the usage of the brackets here, when I create an array, is used to tell me how many elements there are going to be, and that this is an array. When I use the name and then brackets, that tells me which element I want to access. Which int do I want to change? Which int do I want to use? In this case, I'm using int number 7. So values 7, values index 7 equals 10. So if I had 15 ints, I'm taking number 7 and I'm setting it equal to 10. And you can access any element this way. So that's how you access the individual versions of the ints inside the array, the individual sort of pieces. So think of it like, you can kind of think of it like a table, for instance. I have a table, I got 15 integers. I can access each individual element by using brackets and a number after the name. So kind of like this. Here I have an integer array, so I have back to that counts. Integer array called counts equals new int with 8 integers. So if I say counts 3 equals 10, it's going to change this value. Notice we start at 0. So even though I say I have 8 elements, the maximum index I can use is 7 because I use 0, 1, 2, 3, 4, 5, 6, 7. That's my 8 elements. So if I say counts 3 equals 10, that changes this one. All of the rest of the values are actually starting at 0. They actually just have a value of 0. That's one of the nice things that Java does. It automatically initializes all of your values to 0 or the equivalent. And that sort of or the equivalent sort of comes in later. For numbers, it's going to be 0. For something like Booleans, it's going to be false. They would all be false. If you create an array of Booleans, they start as all false unless you change it. So that's how I can access a particular value inside of my array. So when you think of an array, think of this style of picture. You've got a whole bunch of them in here. Each one has their own index. And when you access a value with the index, you can change what it stores. When it comes to this picture, this sort of idea here, this is basically the sort of the basics of arrays. This sort of one slide is sort of how you can think of stuff as laid out, how you can access elements, how you can create arrays. Does anyone have questions on this stuff? Because arrays are going to be probably one of the structures you use the most in computer science, one of the structures to hold multiple values. Does anyone have questions here? Okay. All right, so index always starts at 0. And then you can say that it goes through size minus 1. So we had that size 8, right? We had that new int 8 in the last slide. So we're going to go from 0 to 7. That should make sense because we would have 8 minus 1. That gives us our 7. So the only indices possible in that array that we created just a moment ago was 0 to 7. 7 being the last one, 0 being the first one. Java has some built-in niceties. You can always get the length. So whatever your array name is, so this would be the name of the array, you can always get the length of that array. This is going to be equal to that size. So if you have 10 elements in the array, array.length will give you 10. Whatever the name of the array is. So counts.length will give you 10. But the last index is always this length minus 1, because we got to go 0, in that case 0 to 9 for a 10 element array. So that is something to be aware of, something you'll have to get used to. Not all languages do this. Some languages do start their array indices at 1. Some languages you can actually choose. You can choose to start your index at a negative value. Java does not allow you to do that. So Java will always be 0. In fact, pretty much all C-like languages always start at 0, go to size minus 1, never let you change the starting index. For a lot of the nuclear physics stuff I did, we used Fortran. Fortran is automatically, it has you start at 1 by default, and then you can change it. You can have it be start at 0 if you want. You can have it start at negative numbers if you want. Fortran is sort of free and open in that. But Java, you will always start at 0. So arrays do not start at index 1. Array indices don't have to be hard-coded. So this is where some loops start to come in as well. Typically, if you have an array, you're going to have a loop that also interacts with that array in some way. So this is why we sort of talked about loops first, because arrays and loops are very closely related in how you use them. So if we just look at this sort of one line at a time, we see that we've got a double array called temperatures. It contains 64 doubles. So it's a new array. So a double array temperatures is a new double array of size 64. So for my loop here, I'm saying sort of the standard sort of loop stuff we did before, int I equals 0. But now I have I less than temperatures.length. So let's think about I. Think about what I is doing. It starts at 0. So I is going to go from 0 to less than temperatures.length. Temperatures.length is 64. If we're going to less than 64, then that means we're going to 63. We're going to equal to 63. As soon as we hit 64, we're no longer less than 64, and so we're done. So I, in this case, is going to go from 0 to 63 by increments of 1. So it's going to do 0, 1, 2, 3, all the way to 63, and then it will be done. Notice what happens here in the line that we run in the loop. Temperatures I equals 50. So we're looping through every single index. The first time through this loop will be temperatures 0. Then it'll be temperatures 1, temperatures 2, temperatures 3, all the way to 63, which is the last index in our array. We go from 0 to 63 for our array. Once 63 gets set to 50, the loop ends because we go to 64. That's the condition becomes false. We're done with the loop. So what this code does, and that's the little pop-up I have here, what this code does is it sets every element, all 64 elements in temperatures, to a value of 50, and it does it in a loop. Otherwise, I would need 64 lines, or the equivalent of 64 lines, to do this, and I'd have to type in everything manually. So this is why loops are used with arrays, because you can loop through the index and then modify the values of the array inside of a loop, rather than manually typing in temperatures 0, temperatures 1, temperatures 2, and so on. So the usage of this loop with the array, does anyone have questions on this? You'll be doing this a lot in the future, I guarantee it. Sometimes it does take just sitting down with a small snippet of code. Let's say you are looking at somebody else's code, or you're working on something for a homework or a lab or whatever. Sometimes it does take just sitting down and thinking about, what do I want to do? I need to loop through every element of the array and change it to a value. So start with, how do I loop through every element of an array? What value does it need to be changed to? What's the size of my array? Those sorts of things, those sorts of little things to think about, will help you write more complicated code, breaking it down into sort of smaller pieces. I need to create an array first. Then I need to figure out, how do I loop through all the elements of the array? And then you can start thinking about what value it needs to change to. So it's a lot of these sort of little pieces that you can put together to get something that is a bit more complicated. All right, so when it comes to arrays, there's something common that happens to programmers all the time. It happens to me all the time. It'll happen to you guys when you're working with arrays on homeworks and stuff. It's this out of bounds idea. So you want to ensure that your program only uses valid indices. Remember, 0 to the size minus 1. You can never access an index of less than 0. You can never access an index greater than or equal to the length of the array. I do say equal to. If I have a 64 element array and I try to access element 64, that one does not exist. So equal to or greater than the length of the array does not work. So here's an example of some sort of okay and not okay ones. So again, think about the array. I have an integer array called my array. This is an integer array of size 10. So my valid indices here are 0 to 9. So the first two lines are okay. 0 works, 9 works. I can set it to a value or access the value, do it any way I want to. That's perfectly fine. And anything in between 0 and 9. But if I try to access a negative index, this will give me an error. And if I try to access an index greater than or equal to the size, it's going to give me an error as well. The typical error you're going to see is if Eclipse doesn't sort of warn you about it first, you're going to see this error. So you'll get a bunch of red text, and you'll see array index out of bounds exception. So I will show you that here in just a second. When we start doing some coding, I'll show you sort of what this looks like, or what you can expect to see if you do try to go outside the bounds of an array. It sort of sounds easy. It sort of sounds obvious, like, yeah, well, I'll just make sure I never go outside the bounds. But that's not it's not always sort of as easy as it sounds to follow this sort of out of bounds rule. All right, so let's look at a particular piece of code here and sort of figure out what it's going to look like, or what the array is going to hold, or what it's going to print. So I have an array of 4 ints called vals, and I'm going to put a little sort of table up here. So I want to have the index and the value. So we'll actually write them out here. Because I have a size 4 array, I have index 0, 1, 2, and 3. So those are my 4 indices. And you can do stuff in whatever order you want. So I put a few things out of order here. Vals 2 equals 3. Okay, so index 2 has a value of 3. Vals 0, that's my first index, has a value of 2. So up here, the index 0 gets a value of 2. Vals 1 gets a value of 1. Now I have something slightly different. Vals 3 equals vals 2. So you can access the elements and use them just like you would a regular variable. So what is vals 2? Well, that is a 3. The value that's stored in there is 3. So vals 3 equals vals 2 is just this. I put a 3. The value in there is a 3, so that one gets put here as well. The for loop is going from, change color here, is going from 0 to less than vals.length. So it's going to go from 0 to 3, increasing by 1. And I'm going to print out as a double and a new line each of the vals, one after another. So because I've written out a table, I can see that, okay, this should print out vals 0 first, which is going to be, so the actual print here is going to be a 2, a new line, so the number in a new line, and then it's going to print out vals 1, so that's 1, and then 3, 3. So it prints it out, in this case, in the order that they are in the array. So that's what I would get here as the output to this code. Are there any questions on that output? All right, so I have a quick little exercise. This is only a couple lines, so it's not going to be too long. But I want to show a couple of things, sort of think about, again, sort of how I go about sort of creating some of this stuff to start out with, and then I'll show you what happens if you go out of bounds. So we're going to create a quick program that creates an array of 1,000 integers and initializes them all to the value of 1. So we're going to do a few sort of extra things here. So I'm going to delete what I got here and the overloaded functions that I created earlier. So I want to create 1,000 integers. So I'm going to start with the type, whatever I want them to be, and I'm going to say to myself, either in my head or out loud, I'm going to say I need an integer array. So I'm going to put an int and 2 brackets, open, close, square brackets. I'll give it a name, so I'm just going to call it A for array. And I'm going to say that equals a new array, or a new int array of size 1,000. And no space between int and those brackets. I think you can actually put one in there. Like that'll still work fine. When I save, it does the auto format, so it moves it back, but it should still work fine with the space in there. So that's my array. But if I print them out, so let's say I print out one of the elements. So let's say I want to print out their integers. So I want a %d. I'll put a %n in, and I'll say a 542. So I'm going to print the 542nd index value here. It's just 0. They're all going to be 0. Well, I said in the sort of exercise, sort of a problem, that I want to initialize all their values to 1. So I could do this. I could say a 0 equals 1. and a 1 equals 1, and a 2 equals 1, and we can spend the rest of the class time typing these in, and we probably wouldn't get to all the way through to all 1,000 of these elements. So we need a loop. We need that faster way to do it. We need a loop. This is the same as that temperatures one that we saw on the slides. So I need my loop. So let me throw that in. So 4, we're going to have int I. That's going to be my index, my counter variable. We're going to start at 0 because that's the first element of my array. And we're going to go to I less than a, my array name, dot length. And if you're having the sort of autocomplete stuff come up, it should show you the functions that are available, and one of them is length. In this case, length actually is a property rather than a function. And then we have I++. So we're going from 0 to less than 1,000. And then I can just say AI equals 1. And I can print out that same element again. So I'm going to copy that print line and do that. So first, before we did the initialization with the loop, it printed out 0. Afterwards, it printed out 1. So we did ensure that at least some random value that I picked did get set equal to 1. So that's how you go about thinking about arrays, and then thinking about what can I do to access particular elements? What can I do to change the values of particular elements? Now, let's say I made a mistake. Let's say I put in a less than or equal to. This is a very common mistake. This is a very easy mistake to make. You say, I want to go from 0 to the length. So I say 0 to I less than or equal to the length. So if I run this now we get some red text. Always pay attention to the red text. It tells you a lot of information. Usually the last line in the red text will be your code. So this says main.java, which is my file. My file here is capital M main.java, and it tells you what line 9. So if I click on this, if I click on the underlined sort of link thing here, it highlights the line that this happened on. The error that we got was this java.lang. That's mostly where the errors are located, and the error is array index out of bounds exception. Index 1,000 out of bounds for length 1,000. So this is telling me I'm trying to use an index of 1,000 for an array of length 1,000 because I put the equal to. I'm trying to go I equals 1,000, and that's not a valid element or not a valid index for my array. So the red text here is telling me something important. It's not going to tell me exactly. It's not going to tell me exactly how to fix the problem, but it gives me an indication. On line 9, I tried to access index 1,000 of my 1,000 element array. That is out of bounds. This is where the crash occurred. Is this where the actual error is for me to fix? No. It's on the line right above. I got to get rid of the equals. So whenever you see red text, pretty much no matter what it's for, try and take that first line and see if it makes sense for something that you've been working on. In this case, messing around with arrays. And then the last line, there might be a bunch of stuff in between. Typically, that's for like other calls and things like that. There might be a bunch of stuff in between, but typically the last line will be your own code. And then you can click on it and it'll highlight the line in your code where the crash occurred. Not necessarily where the error is in the code that you have to fix, but at least where the crash happens. And that gives you sort of an inkling of, okay, maybe it's something around this. Something to do with this loop is causing this problem. Okay, so that's sort of essentially the sort of basic of create an array, set all the values to something. Right, and then I have the sort of solution without the prints and stuff here as well. All right, so you can initialize arrays in a couple different ways. We just saw with a loop, we're essentially creating you can think of it as like an empty array. It contains all zeros or something. But you can actually start it out with some values. So I have the same type and name, but I do something different for the initialization. So I still say an integer array called pages. But after the equals, rather than saying new int and then a number, if you just put curly brackets and you fill in between the curly brackets with values, that will create an array as well. So it's an integer array, so I'm putting ints in here. So I got a bunch of ints. So I've got 1, 2, 3, 4, 5, 6. So I've just created a 6-element array with these values as the elements. This is exactly equivalent to doing this. A little bit nicer than doing this. So if you have a small array, and you'd probably only want to do this for a small array. You wouldn't want to do this for 1,000 values. But if you had a small array, you don't have to type in pages 0 equals, pages 1 equals, pages 2 equals. You don't have to spend the lines doing that. You can just do something like this. If you already know what the values should be. If you're calculating the values in some way, it's probably best to use a loop or something to do it. But if you already know what the values need to be, and it's a relatively small array, then this is a very easy way to initialize an array, to give it values and a size all on the same line without having to do the sort of process that's down here in the little bottom snippet. So we've got a couple more sort of array sort of examples that I'm going to code up, and then that'll probably be about it. So we're going to write a program that creates an array with 10 elements, and I'm probably just going to copy and paste this into the code. But in principle, it can be sort of whatever elements you want. Then we're going to create a second array, also 10 elements, and we're going to copy these elements, the ones that I've listed here, from the original array to the new array. So we're going to do an array copy. Write our own function to do that, or write our own method, or write our own program to do that. So in main, we get rid of this stuff here, and we'll move you down. Go. I'm going to create an integer array called myArray, and open the other slide, and grab those values out. So I think these are the ones from the slide. If they're not, then whatever. It doesn't really matter what the values are. So I created an array. This should be 10 elements. We're going to create a second array. So integer array. I'm going to call this one new array. And it's just going to be empty. It's just going to have those zeros in it. So I can do the new int 10. So my two arrays, one that's already filled, one that has all zeros. I want to take all of these values and I want to put them into this array. We're going to use a for loop to do it. If you weren't using a for loop, if you didn't want to use a for loop, you could do this. It's not that hard. I would say new array 0 equals my array 0. I do the same thing for 1 and same thing for 2 and so on. The interesting thing about typing this in to start with, so if I had a couple of lines of this, so I did 1 and then 2 and so on up to 9. The interesting thing about writing it out this way to start with, without using a loop, is that it can help inform you of how to use the loop when you do write it. Because what's changing? The line here is exactly the same. Both of these lines are identical, except we have a 0 for the first line in both these places and a 1 in that line. That should help figure out what the loop should do. So let's start with the loop. I equals 0. I less than. Both these arrays should be the same size, so we could use either one of their lengths. So I can say myArray.length I++. If one of these arrays was shorter, then we would have to be more careful about which one we actually used here. But both of these should be the same. I think this has 10. Yeah. Now it's essentially this line to do the copy, because we're going from 0 to 9. So if I take one of these lines and I copy it in here, and I just replace the number in here with I, because that's the thing that changes to go from 0 to 9. Then I can do a print. I'm not going to print the whole thing out. I'm just going to print one of the values. So we'll print out new array. Let's print new array index 5. Maybe do that before and after the loop. So I'm going to get rid of these manual lines and then run the program. So initially, that new array 5 had a value of 0. Now it has the new array 5 has a value of 56 after doing the copy. So that would be index 0, 1, 2, 3, 4, 5. There's the 56. That's the one that it's printing out. Now you might think, okay, let's do an array copy, whatever. When are we ever going to do this? One of the data structures that also exists in Java that we will talk about later on this semester and then use pretty extensively in CS2 is called an array list. And if you've used Java before, you may have used array lists. This exact kind of copy is one of the key components to make an array list work the way it does. This exact code. So simple operations like copying elements from one array into another are actually integral components in a lot of different applications. Just being able to copy an array like this. So this isn't, even though sort of right now it looks like some sort of trivial, okay, when am I ever going to do this? Behind the scenes for things like array lists and a lot of other operations you may end up doing for homeworks and for personal projects and whatever are just simple sort of operations like this that when together used in the context of your application and do end up being important. So is there any questions about the array copy? We're going to do one more before we're done today. Right. Okay. And then there's a little sort of solution thing here. All right, so we're going to do the same thing again. We're going to have a my array filled with 10 elements. But we're now going to use a loop to sum the values and then print out what the final sum is. So that would mean that essentially, sort of, you were doing this by hand, you would say 10 plus 9 plus 8 plus 7, all the way down to 1, and you'd print out what that value is. So that would be, what, you got 10, 20, 30, 40, 55 is what this should be. So we'll see if we get 55 in the end. So I'm going to keep my array. And we're just going to put in the 1, 2, 10, like that. So we've got my array. We want to have a sum. So we want to print a sum at the end. So I'm going to put that in first. I'm going to say int sum equals 0, because that's where the sum would start. And then I'm going to put the print in here. System out printf. And we're going to say, I don't know, the sum is %d, %n, and we'll print out sum. So right now it would print out 0. Of course, we haven't really done anything yet. We want to add up all the elements in that array. This type of sum, summing up everything in an array, is also a very key operation in a lot of different contexts. It's one of those little small pieces that are used in a larger context. So the way I sort of manually did this, the way I sort of manually described this, was I need to take, and I sort of did it from the right end here, but if we do it from the left end, I would need to take 1, and then so index 0, and I would need to add to that the value in index 1, and then add to that the value in index 2, and then add to that the value in index 3, and so on, all the way to index 9. So whatever value is in those indices. So think of it kind of like this. If I sort of wrote it out like this, I could say sum equals my array 0 plus my array 1 plus, and so on. And that can sort of keep going until I put them all in there, and then I could print out sum. That's not ideal. This is only a 10 element array, but what if you had a 1,000 element array you wanted to do this on? So that's not what we want to do. We do want to use the loop for this. But in the end, it's a similar thing to what we just did. The only thing that really changes between each term, so between me starting with array 0, I add index 1, and then I add index 2, then I add index 3, whatever those values are. So again, it sort of helps us with the loop structure to think about sort of the manual process that you would go through. What would you do if you were typing this in on your calculator, or if you wanted to just do this manually in code? So I would say I equals 0, because that's where we're starting. I equals 0 to I less than my array dot length, I plus plus. So I got the array, it's going to loop through everything. This one's a little bit more tricky to understand what's going to happen each loop iteration. Because at some point, we're going to have my array I. That will be in this loop. So every single time, it changes. So the first time through the loop, we're going to get array 0, or my array 0. So if I did this, if I said sum equals this, that might look like it's something you want, but it says the sum is 10. Why? Because that's the last element we looked at. That was element 9, and I said sum equals whatever's in element 9. So that's not quite what we want. It's close, but not quite what we want. What I'm going to show you is what's called, it's how you use an array to compute a running sum. So I'm going to show you this. We're going to add this in. So right now I'm saying sum equals sum plus my array. So my array I. So let's think about what happens on the first iteration. I can draw a table like this, and I could say this is going to be I, and this is going to be sum. So before we even start, so I'm just going to put something in here like an X. So before we start this loop, sum is just 0. Before we even start. Now let's say we're in the first iteration of the loop, I equals 0. Well, what is sum? So just look at the right-hand side of the equation. What is sum? Sum is 0. What is my array? 0. I is 0 for the first iteration. What is my array? 0. It is 1. So our sum here gets set to 1. Okay, should make sense, hopefully. Eraser it. Now what about the next iteration, when I equals 1? Well, the previous value of sum was 1, so we have a 1 here. Then we're adding my array index 1, which is a 2. So this will be 1 plus 2, so that means that sum will be 3. It's the running sum. 1 plus 2 is giving me that 3. And you can keep going like this. The next one is going to be, the previous value of sum was 3. My array index 2 is 3, so that's going to give me 6 for I being at index 2. So this is a running sum. We're keeping track of the current sum as we move through the array. So it's basically me going 1 plus 2, that's 3, 2 plus, this would be 3, 3 plus 3, that gives me 6, 6 plus 4 is 10, and so on. If you don't fully understand exactly how this works at the moment, that's okay. But this is something that you will be using many, many times in the future for coding stuff, the sort of running sum idea, having an array full of values and needing to add them all up. So if I run this now, I should get that 55 that I mentioned at the beginning. So it's just adding them all up as we go along. This can actually be shortened. I wrote it like this, so it's hopefully a little bit easier to understand. But remember that we have an operator plus equals. This will give you the same thing. Save it, and we still get the 55. So this is equivalent. Sum plus equals my array is exactly identical to sum equals sum plus my array. So it's the same thing, it's just a shorter way to write it. Okay. Questions on the running sum? Right, and the sort of sample code is here. Okay, so next time, more on arrays. PA3 is due today, end of day, and LA2 will be doing in lab tomorrow. PA4 is also available, so we do have homeworks every week at the moment. So PA4 is available, so you can go ahead and grab that one. PA3 is due at the end of the day. PA4 is due essentially next Thursday, end of day, so the week thing. And then you don't have LA2 available to you guys yet. That'll be available tomorrow morning, but that will be available then, and it'll be the same sort of process that we did last time. I'll talk about it a bit. I'll probably talk about PA4 a little bit as well at the very beginning. I'll talk about LA2, give you some hints on it, and then I'll break you into breakout rooms, and you guys can work together with the folks in your breakout rooms to finish the lab. I know that last week a lot of folks finished the lab just right there in lab class, so that is the best time to do it. But you will have essentially the day to work on it. So in case something happens with internet and all that other crap, you won't have to worry about sort of turning it in late. So essentially, you sort of have the day to do it the way that I have it set up. So that is it. I will see you guys tomorrow morning.
Thank you, Professor.
So yeah.
Thank you, Professor.